YouTube, what's going on? It's Kevin, aka Captain America, aka Captain North America. I need to have a second channel because YouTube censored my first one. They've got me frozen. They did a couple quick community guideline strikes on me, tried to appeal them, and they've frozen my Captain America channel. What that means is they're censoring free speech on YouTube, political speech, because that they hit two videos where I was looking at what I believed was a hoax in Charlottesville, that if anybody died, Heather Heyer wasn't hit by a car, right? They said she died of a heart attack, but the mainstream narrative was that she died as a result of the car crash, which to me is more of their fakery. This is a totally unrelated video, but if you're looking at this, I have another channel called Captain America. So this is about the paradigm of the Earth, the planet that you live on, and there's so much great content out there, and I'm just trying to do my part to add my own thoughts and perspective. When we're talking to people about where we live, we have to look at what we're being told about where we live and the sources of where that information is coming from, and then go, okay, what can we prove and disprove based on the information that we're being provided? So most of the idea of where we live is given to us by astronomers. They spent time, these used to be astrologers, so the idea of astronomy is really looking at the sky at night and trying to figure out what those lights in the sky are doing and how that relates to us here on the Earth. And to me, the Earth is a motionless plane, and it's just the star field that's moving. Because when you use a second frame of reference, right? So if you're on the Earth and the stars are moving and you're trying to figure out which is moving, it's just like being in a car at the traffic light. Something moves next to you, you hit the brake to see if it's you that's moving, you're rolling, or is the car that's next to you, or are you both rolling, right? If you hit the brake, you know that you're not moving, it's the car next to you. So when we look at the Earth and the consequences of rotational energy or angular momentum, sometimes referred to as centrifugal or centripetal force. In the Earth, we have the centripetal force is we would call it gravity. There's a force that holds us to the Earth, right? And then you have centrifugal force, or the rotational energy of the planet. And typically what we have is people only refer to one energy at a time. They just say, oh, let's just focus on whether or not the planet is rotating. But in the heliocentric paradigm, with what modern astronomy is saying, the Earth is moving in multiple simultaneous directions at the same time. The entire universe is expanding at the speed of light. I think they're just telling story after story, and one story gets more fantastic than the next. Because they're just bought into this cult. I think they may really believe it, but they're just referencing the movement of the star field, and they're not looking at the implications of motion as it would here on Earth. There would be implications to our movement. So this is where my investigation goes, okay? So let's look at the paradigm of what we're being told. So what we're being told, now this is borrowed from Dan Dimension's video, Flat Earth, Actual Speeds. Thank you, Dan, you're the man. Appreciate his videos. He's got some really beautiful high altitude balloon footage of the motionless plane where you live. But let's take a look at this. So this is one visualizer. So in this video, Dan goes through the multiple simultaneous motions that are being provided to us through modern astronomy. So what they say is that the Earth is traveling this way at 420,000 miles per hour. With the sun, right? Okay, let's say the sun is going this way at 420,000 miles per hour, and then the Earth is orbiting the sun, which means it's also moving that way at 420,000 miles per hour, while it's carving this orbit around the sun, which requires it to travel in this orbit at 66,666 point blah 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 miles per hour. So I thought, and then the Earth is also rotating to give us that our day and night cycle. So let's break these down into manageable numbers for us. So 420,000 miles per hour is roughly 111 miles per second. The orbital velocity around the sun is approximately 18.5 miles per second. And then the rotational energy of the Earth is approximately 1,500 feet per second, or about a quarter of a mile per second. Okay, so that's what we're being told about the speeds of the Earth. And you can go through this video of Dan's. He does an awesome job You know, he literally takes you to the end here where he pretty much tells you the final velocities here, that ultimately we're moving at speeds in excess of 2.7 million miles per hour in 5 different directions. But he gives you high altitude balloon footage here where you see the sun appearing to be local, not 93 million miles away, just another fictitious number that we've been provided with all these nonsensical fairy tale Bigfoot unicorn storytellers at our universities that we defer to and pretend like these guys know what the hell they're talking about, when they're telling you about planets and Goldilocks zones and all the rest of it. And when you find out how they know, you just go, ah, man, these guys are so full of it. So Antonio Subirats has another visualizer here where it literally shows the carving of the parabolic of the sun as well. So while all of the planets with their orbital moons are traveling around the sun is also carving a parabolic through the galaxy, which then is also traveling through the universe, and then the entire universe is traveling. And I wanted to highlight this video as well. It's called Flat Earth Tap Dancing Seahorse Astronomy, and that's by a gentleman, his name is Antonio Subirats. Antonio does a phenomenal job in his videos. There's so many great content providers out here on YouTube, but I just thought it's important for us to take a look at what's being provided to us and then kind of put us into a framework where we can experience some reality. Because I think what happens for a lot of people is something can be made plausible to where it makes sense theoretically, but in actuality it's not reality in reality, right? So that's the problem I have, is if you just say, oh, theoretically here's the way the math works. Oh, the distance, the size of the circumference of the Earth, and your sensation of angular momentum, and the stuff that guys will come up with. And they'll talk about one motion at a time because they really can't reference all of them. Because if they did, they can't even do the math equations because they're so complex. We can visualize them, and we can start talking about, would we really not notice the Earth traveling in multiple simultaneous motions? So let me put it to you this way. If you were out in space on Elysium, and Elysium rotates, the rotational velocity causes a sensation of gravity, right? That's the other way that they'll say you can experience gravity in an otherwise weightless state, because of the mass of the object isn't large enough to create the kind of gravity. And to me, that's all fiction, that they're just playing with something that's plausible, that seems to make sense, because you do have an experience of something holding you to the ground. We call it gravity. We have this phenomenon, but they're trying to reconcile why what they see up in the sky at night, what holds them in place, what allows the planets to have an independent orbit from the star field, what keeps Polaris over the North Pole for eons, right? I mean, for recorded history, we've had the North Star. There are visual anomalies in the southern latitudes, which most of us will never get a chance to experience. So again, we just are dealing off of hearsay. We've never been to space, so everything is based on hearsay. 7.3 billion people on the planet. Somewhere over 536 people have ever claimed to even gotten into high Earth orbit. NASA claimed to put 12 men on the moon back, the last time in 1972. I can't imagine what other technology has gone farther backwards than our space program, but it's because they probably came to the realization that whatever's up there, it's not what they thought, and it's not what they've been telling everybody. And if they continue to make money off of all this stuff, they have a system that works for them, raking in $19 billion a year. Why would they upset their apple cart and maybe go to jail? Okay? If the people found out what they were telling them, everybody was fraudulent, and we would go, what were you doing with the money? Oh no, we're using that to poison the atmosphere now. So here we have a cups and saucers ride. So anybody who's detached from reality, take them here first before you start talking about the Earth. If you can. If you can get them onto an amusement ride where they have to experience multiple simultaneous motions. So we can look at 3, right? So here we have like a rotational velocity, then we have an orbital velocity. Where's my mouse? We get rid of these advertisements, right? So this is carving a rotation and 2 orbits. Right, so you have the center post here, These are rotating. They're carving a smaller circle inside of a larger circle. And then if you shot it that way at 2 million miles per hour, and then the universe is expanding at light speed, then we're starting to look and feel like what we're being told about the Earth that we live on. But as you'll notice, whenever you have rotational energy, you always have to be held against something in order to keep from being thrown out on a tangent. That's what rotational velocity creates. Now, guys always go, oh, it's the size of the arc almost draws a straight line. But, you know, speed matters too. So the actual velocity matters, right? So here on the Earth, you know, velocity matters for us. So let's take a look at an amusement ride. I'm going to have to, I forgot to pop in one video. I'm going to have to add it here after this one. But let's just take a ride on a roller coaster. So you know that when you're on a roller coaster, you have to be held in to the roller coaster in case you get thrown off on a tangent. And you know, if you're one of those people who likes to watch other people's worst day, you can come out and you can watch a roller coaster where people get thrown out of the roller coaster. But here I thought it would be nice to look at one of the top 10 roller coasters. And a flat earth and a GoPro camera. Okay, here we go. So this is you on the outside of planet Earth, traveling through the universe in this wicked parabolic that we do with the sun through the galaxy. And of course it's not changing direction, but you know, just kind of giving you some experience of, you know, parabolic arcs, right? And the impact of the movement creating what we would call centrifugal force. Okay, and you have gravity acting on the people as well, which causes a very unique phenomenon, which in space, without a large gravitational body, as they would claim, you know, you would just have the rotational energy that would cause a centrifugal force. And then, you know, how would you control that if you couldn't create thrust in space? So there's a lot of problems with the idea of space. But I thought, you know, when people want to get involved in theoretical stuff, it's important to actually get involved in reality. So here was a fun one. This, I believe, was a pretend amusement ride called the Centrifuge Brain Project. Watch all these videos because it is hilarious. Okay, so I think this is awesome because this is a visualizer of a rotating planet. So here you'd have, in the center of this post, you'd have what would be relative zero, right, to the kind of distances that you'd be traveling at the, what would be the equator of this ride versus, you know, the nominal speed you'd experience here to almost, you know, the sensation of very little motion, and there'd be very little impact on the rider as compared to anybody who was out on the upside of the globe. When I first saw this, you come quickly to the point where you go, okay, this is imaginary, because people would die on these rides. And in one of the videos, he's like, oh yeah, well, they were on the ride for 12 hours and then they got stuck on the ride for another 12, and that made people uncomfortable. This is a funny video, but go out and watch it. I think this is important for you to kind of get a frame of reference, even if you just showed this to somebody. They're like, oh, the Earth rotates. But the impact of the relative motion to the distances being traveled over time, that's what we experience as centrifugal force. And gravity, you know, the pull on each of these cords as they went out, if you were to, you know, use it as a weight of measure because of the distance from the center, and if you had a really long string, the amount of force that would be on, or tension that would be on this, would vary as you go up here, but in their equations they don't give a shit about any of that. So I thought it's important to focus on rotational energy, right? So the Earth is supposedly doing these multiple simultaneous movements, and yet we can have a tall tower like this that as soon as you rotate the tower, you know, people start to fly away from the center of rotation, and the Earth, which is supposed to be rotating at 1,500 feet per second, or about a quarter of a mile while it's doing multiple simultaneous motions. If we just took 3 and said we're traveling with the sun, which is at 111 miles per second while we are orbiting the sun at 18.5 miles per second while we're simultaneously rotating, we have multiple simultaneous motions, and yet we don't experience any of that on flat Earth. The problem we have with video footage sometimes is they use the GoPro lenses, and GoPro will curve. And then people go, oh, I saw the curve. Well, what you saw was a lens distortion because of the GoPro camera. And when you see them, they'll resolve like this. You know, the GoPro camera will make a bowl or it'll make a ball depending on where it is, how it's oriented, right? So, but here on Earth, in Dubai, over the towers of Dubai, you have all of these cranes with objects of extreme weight hanging from them by cables. And they don't experience any of the different swinging that you would have if the Earth were actually in motion. And they could say, oh, it's at a constant velocity, but not everything's pointing in the same direction. Okay? And I want to focus on this idea that we have. So you're provided a concept that everything you experience is just as if the Earth wasn't moving, right? But then you're told that it doesn't matter whether or not we're moving because you wouldn't notice any motion. And I think that is dumb. Okay? So here we have the experience of moving atmosphere. So if the atmosphere were rotating with the planet, okay, and if we just took the rotation, said the planet's rotating at 1,000 miles per hour roughly at the equator. And you have the Coriolis effect, which says, you know, they kind of get confused, right? They'll just say, oh, the atmosphere moves with the planet, and then sometimes they'll go, the atmosphere doesn't move with the planet, because it doesn't make sense. The atmosphere either moves with the planet or it doesn't. So if you're saying it moves with the planet, somehow gravity acts like Velcro on gases, which seem to flow in whatever direction it feels like, and you can go outside and, you know, you can light a match. You can light some incense and the smoke just rises, and it doesn't really care about moving atmosphere, even though the impact of the speeds would put 2 vortexes at the poles. Okay, you know, but people don't really seem to give a damn about the impact of the rotational velocity on the Earth because they think it wouldn't matter. So let's take a look at what happens when the atmosphere really moves. This is a 109 mile per hour wind. And this guy is literally sitting against the atmosphere because when the atmosphere moves, it has built-in resistance. Okay, so he's allegedly attempting to, you know, they're saying it's 109 mile per hour gusts. I don't know what the constant wind speed was. You know, he's on ice, so I'm guessing it's probably 50 to, you know, and then up from there, maybe 70 to 80 and then beyond. But, so this is just to demonstrate that moving atmosphere would have consequences. Even if you're moving with the atmosphere, okay, like he could go that way at 100 miles per hour and he wouldn't experience the resistance in the atmosphere because he'd be moving with it. But as soon as he turns into the atmosphere, he would experience the consequences of the moving atmosphere. So he moves with the atmosphere, right? And as soon as he tries to come into the atmosphere, he would experience the resistance built into the atmosphere, okay? So the aerospace industry utilizes wind tunnels because they know the way physics operates, it doesn't, you know, our understanding of physics, right? So it doesn't matter if it's my fist that hits or my hand or my open hand that hits, the experience is the same. If they're both moving, then it's going to be increased, right, based on the fact that they're both moving. But essentially, if I'm in the atmosphere and it's not moving, but I'm moving, I have an experience of it. If the atmosphere is moving and I'm not moving, I have an experience of it. And if I'm moving through the atmosphere, right? So atmosphere, wind, and then water have resistance. But guys will try to discount that because they don't need to, really, because the atmosphere only moves gently most of the time with you know, over the motionless plane, but it's pulled by the electromagnetic properties of the sun and the moon as they pass overhead. They pull the tide, right? They heat and cool the water, and that causes a convection current that creates our weather systems, okay, mostly, right? So in a 120 miles per hour vertical wind tunnel, again, if you were moving at 120 or the atmosphere is moving at 120, it's essentially the same. But in this case, you could fly. Like he was in gusts, but they essentially move the atmosphere and then you could fly. So the resistance that's built in the moving atmosphere allows you to fly, and yet they're claiming that the Earth is rotating and the atmosphere is moving at that speed. And then they want to pretend like that wouldn't have any consequences. Well, if you're on the planet and you're moving in the direction of the atmosphere, and I go that way, okay, as soon as I turn against the atmosphere, you know what happens? Is you experience resistance. And yet, in our minds, we have this cognitive dissonance that says, no, I never experienced that. I can move freely out my front door, left and right, north and south, east and west, without any problem, unless there's a weather event. Okay, so when the atmosphere really does move, we experience it. But we're trying to be convinced that the fact that it's already moving wouldn't have any consequences. It's kind of like being on the roundup ride and then trying to crawl in the opposite direction of the movement of the roundup. That's much more difficult than moving with the direction of the roundup. Okay, and you don't experience anything like the multiple simultaneous motions that they're claiming because it's all bullshit. Okay, that's where I'm going with this, because this is the break, is the atmosphere and water. You have a gaseous planet, right? Gaseous atmosphere, but it's stacked and it's layered this way. It's not like the depictions of Saturn and Jupiter where the striations of the atmosphere are, it's kind of like, you know, the way that the individuals are hanging off that giant ball on the swing, right? You'd have striated atmosphere in the way that they depicted on Saturn and on Jupiter, and those are just illustrations, by the way. They're not real images. When you look at real images, it doesn't look anything like that, okay? So I thought you should look up the Fujita scale. This is what happens when atmosphere moves. It's called a Fujita scale. They use it for tornadoes. The highest wind speed ever recorded on the planet was, who knows? They said it was 340 miles per hour. An F5 tornado is from 261 to 318 miles per hour. It causes incredible damage. The F6, they've called it the inconceivable tornado because they don't really, like I said, they don't really ever record wind speeds that high in tornadoes, although they claim that there was a wind speed that high at once on the planet. The reason why I bring this up is if the atmosphere is moving, right, and we have this, where is this thing here? Right, so if you think of this as the atmosphere, you notice that the speed that would be here, because of the distance that's traveled versus here, you would have this vortexing effect of atmosphere. So our planet would be completely unlivable if we could maintain atmosphere at all. That's the problem. Now then, that's not even talking about water. People get really confused, right? Because everything, that the planet we live on, everything is consistent with a motionless plane, and yet we've accepted the belief that we're already in motion. Right? So we've completely discounted all of the actual physical impacts of motion and what would happen to water and gas on a planet that was rotating. And I had another video that I put up where I actually borrowed some footage from Interstellar, but because it's a Warner Brothers thing and they have an agreement with YouTube, even though it's a fair use of the video, they blocked that video, so I'm doing this one. And hopefully I don't get any copyright things for this, but to me, I'm changing the content here. So here you have a guy surfing a ginormous wave. But if the Earth were rotating at 1,000 miles per hour at the equator and there was a difference in the velocity of the water on the side, you'd have this incredible turbulence, and you would have that wave like you had in Interstellar, where the entire planet would be constantly in motion, and you'd have turbulence because of the differing speeds associated with a rotating planet. I think since water flows more easily than land, you'd probably only have water at the equator, you wouldn't have any land at the equator, and yet nobody seems to give a shit. That's because they live on a motionless plane. They only believe that they're moving. Okay? Water moves. Again, and this is because of the impact of the sun and the moon moving over the surface of the planet. And Antonio has another video which really shows this nicely. I'm sorry, Antonio, I just wanted to borrow one of your videos. I didn't have it pulled up already. Okay, because people always go, oh, how does it really work then? We can skip this in 2 seconds. I should have had this pulled up already, but whatever. Okay, so this was borrowed from Jeranism. So if the sun and the moon are carving their circular pattern over the earth, this is the flat earth visualizer from Google Weather, and it makes sense. As the path of the sun travels over, we have a cold core, although the temperatures don't really look like it, and then you have a cold outer ring, and then who knows how far the plane goes out in that direction. There are other maps that show beyond what we have as Antarctica, which is mostly ice wall, and there's other continents outside of that. This is a visualizer for how the weather operates over the plane of the earth. And this is rational. This makes sense relative to the motions. And here the tides are interacting with the land masses, right? And then you have the greater oceans on the outside. And this is movement of atmosphere, which would also probably reflect the movement of water as well, the heating and cooling of the atmosphere and of the water. So I just wanted to quickly show that one because I think that makes a lot of sense when you look at and you try to use visualizers that are representative of what we believe reality is, which is a motionless plane. Okay? So again, here's your visualizer, multiple simultaneous movement, and yet we're trying to be fed a story that none of this motion would be represented on the earth. And that's my issue with anybody who says, oh, you just skipped out of high school physics. No, I didn't. I didn't skip out of high school physics. Math is a great tool, but it's a tool. It's there to help you describe what you're seeing and experiencing in reality. It's kind of like musical notation for music. You can play an instrument without knowing how to read music. You can understand physics without knowing how to do the math. And I think, in some case, the way we communicate things, they've put it in a language that most people can't understand. And they've tried to put it out of reach for you to see, feel, and experience so that you really just are disinterested in it, so they can continue to take billions of dollars annually and give it to these aerospace companies, pretend like there's no more land out there, and keep us on a ball when we probably live on a flat plane or a motionless plane that people would want to explore because they'd want to get out of this banking trap that we're all in. They're treating us like the free-range Purdue chicken, where they move the fences around. So that's this video. I know it's a long one. I had a lot of different video clips in there that I wanted to show you. I'll probably break this down into smaller bites for people. If you didn't want to sit through a full 30 minutes or you wanted to demonstrate one of the points that I'm making, I'm going to put them into separate sections so you can then just show that one section that you wanted to provide for anybody. So like, share, and subscribe here. Please subscribe to my other channel where all the rest of my content is, called Captain America. You're awesome. Thank you so much. Have a great day. Peace.